Hello, how you doing? It's MrDoTheMath, and today we're going to solve system of equations with 3 variables, right? For a system, I don't know what their first word is. Yours is blocked out too. For a system that has 3 variables, then we must be given 3 equations, right? So we're going to be dealing with 3 equations to solve this, right? 3 equations to solve this, right? And let's just walk through the steps to do it, right? In order to solve it, you want to use elimination or substitution to get down to a 2-variable system, right? You're going to use elimination or substitution to get down to a 2-variable system because you're going to have, for instance, x, y, and z, right? And then in order to avoid mistakes, we're going to label our equations and computations. And then you're going to solve the 2 variables through elimination or substitution, right? So if we're looking at this example here where we have 3x plus 2y plus 4z equals 11. We have 2x minus y plus 3z equals 4, and 5x minus 3y plus 5z equals negative 1. All right, so we got 3 equations, 3 variables. Step 1 is you're going to choose 2 equations to cancel a variable, right? You're going to choose 2 equations to cancel a variable, right? And notice they said to label these. So we call this equation A, B, and C, right? So basically what you're going to do is you're going to choose 2 equations to get something to cancel out, right? And then once you down to 2 variables, you're going to do the same thing again, right? So step 1, let's choose A and B. So we choose equation A and B. We got 3x plus 2y plus 4z equals 11. And you got 2x minus y plus 3z equals 4, right? These 2 equations, let's cancel out the y, right? So we're going to cancel out the y. In order to cancel out this y, we're going to have to multiply the bottom equation by 2. Y'all with me? Everybody with me? Yeah, give me a head nod. So you distribute through, bop, 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 and bop. We'll rewrite the whole thing. So we got 3x plus 2y plus 4z equals 11. And then we got 4x minus 2y plus 6z equals 8. Right? The goal is to cancel out the y, which we did. So we cancel the y out, and we just add everything together. So that's 7x plus 10z equals 19. Right? So now this equation has 2 variables. All right, we're going to put that over to the side. Right? The next step is to choose a different pair. 2 more equations to cancel the same variable. Right? So whereas we did A and B, the next thing we want to do is let's choose the last 2. Let's choose B and C. Right? So this is A and B. All right, we're going to take B and C now. So that's this equation and this equation. And our goal is to cancel out our y still. So we got 2x minus y plus 3z equals 4. And we got 5x minus 3y plus 5z equals negative 1. Okay? For this equation, to get the y's to cancel, we're going to multiply the whole thing by negative 3. So we're multiplying this one by negative 3. So when we multiply it by negative 3, we end up with negative 6x here. We'll get plus 3y minus 9z equal to negative 12. Everybody good? Does everybody see that? Give me a head nod. Let me know we're good. Okay. So we distributed through to get the y's to cancel, which they did. So we got negative 6 plus 5, that's negative x. Negative 9 plus 5, which is minus 4z. Negative 12 minus 1, negative 13. Okay? So now we have x and z, x and z, x and z, x and z. All right? So we got two variables. Now we have our original two variable system of equations. So we're going to take these two and we're going to solve. So we got 7x plus 10z equals 19. And we got negative x minus 4z equals negative 13. Okay? Let's cancel out the 7. Let's cancel out the x. Right? So we cancel out the x, we're going to multiply the bottom equation by 7. So that'll give us 7x plus 10z equals 19. And we got negative 7x minus 28z equals negative 91. So 91? Yeah, 7 times 3, 21. 7 times 7, negative 91. Okay? Everybody good so far? So we did 7 times negative x, 7 times negative 4, 7 times negative 13. Okay? Here we go. The x's cancel. We have 10 minus 28, that's negative 18z, and then 19 minus 91. 19 minus 91. Yes, sir. Huh? No, different sign, subtract, so you gotta subtract. 19 minus 91.
Oh, okay.
19 minus 91.
Negative 7.
Yeah, negative 72. Right? Negative 72. Divide both sides by negative 18. Z equals what? 4. Z equals 4. Right? Alright, so what did I do? I chose two variables. I chose two equations to cancel one variable. Chose two more equations to cancel a variable. Then the next thing I did was I solved by a system of two variables, right? That's what this was. That's what this was, right? Right? Solve a system of two variables. The next thing you want to do is you want to substitute the solution into step 2. All right. So we're gonna take this z and we're gonna plug it into one of these equations, right? So let's say negative x minus 4z, which was 4, equals negative 13, right? So that'll be negative x minus 16 equals negative 13. Okay? Add 16 to both sides. X is going to equal, did I write this right? I want to make sure I wrote it down right. Yeah, x is going to equal, negative x is going to equal positive 3, right? And then you divide by negative, you're going to get x equals negative 3. Okay? Everybody good so far? Right? Now, after you solve that, you have 2, and then finally you want to substitute the two solutions into an original equation. All right, two solutions to an original equation. So you got x and z. We can plug it into the first equation. So it'll be 3 times x. Let's make some more space. Make sure I got enough space. So you got 3 times x plus 2y plus 4 times z, which was 4, equals 11. All right? So now we're just solving for y. So that's negative 9 plus 2y plus 16 equals 11. Negative 9 plus 16 is 7, so that's 2y plus 7 equals 11. Subtract 7 to both sides. 2y is going to equal 4. Divide by 2. y equals 2. Right? So your solution is x, y, z. Ta-da. So that's that. All right. So everybody got this? I'm gonna stay in this space and we'll work on the second one. If you got this, start swinging at the second. Right? Look at the second one. Again, you're gonna choose two equations and cancel out a variable. Then you're gonna choose two more equations, right, and cancel out that same variable, like we did here. We canceled out the y's. Then we solved for the system of two equations, right? And then you substituted it back into the canceled out variable, and then you put all of that back into an original, right? So this is step 1. This is step 2. Step 3. Step 4. Where we at? Step 4, 5, and this is step 6. All right. For this one, we got our A, B, and our C again. So, which variable did you all cancel out? X or Y? Or Z? You always cancel out the X? Some people cancel out the Z. Alright, so we'll do it the X because most people said the X first. Alright, so we got X plus 5Y minus 2Z equals 5. This is going to be A and B, right? And then we got 2X minus 2Y minus Z equals -5, right? We're going to multiply this one by -2. So it's going to be -2X minus 10Y plus 4Z minus 10, right? Our X's cancel, so we end up with -12Y, same sign, add and keep, plus 3Z equals -15, right? So that's the first one. And let's look at BC. In order to get this one to cancel, we have to multiply the second equation by 2, by +2, sorry. So then that'll be 2X minus 2Y minus Z equals -5. Then we got -2X plus 6Y minus 14Z equals 28. Okay, so we distributed this 2 through. Bow, 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 bow. All right, 2 times -2, 2 times, that's -6, I'm sorry. -6, 2 times here, I'm sorry, it's plus 14. I'm glad I'm checking. And then that's 28. Okay, cool. All right, so now the X's cancel. We end up with -8Y plus 13Z equals 23. All right, those people that cancel out their X's, did you guys get this situation? Cool. Now, step 3, put these two together and we're gonna solve by system of 2 equations. So we got the -8Y plus 13Z equals 23, and we got our -12Y plus 3Z equals -15, right? Interesting. So now for this one we gotta get one of these two to cancel out, okay? Now, here's what you wanna think about, right? Look at 8 and 12. 8 and 12, they are multiples in some kind of situation, so you can figure out how to get 8 and 12 to find the factors that's gonna get close. So like, let's make this 24, let's make that 24, right? Or did you all multiply this one by 12 and this one by 8? Are you stuck right here? Nothing? We don't know? Alright, so we want to get let's get the y's to cancel out. And think about multiples of 8 and multiples of 12. Right? Multiples of 8, you have a 24 there, like I said, and so you can multiply this whole one by, we gotta get one of them canceled, they're both negative. So you're gonna multiply this one by -3, and then for the multiples of 12, 2 times 12 gives you 24, right? So we found a least common multiple, right? Least common multiple. All right, so let's distribute. So that's gonna give you positive 24y minus 3 times 13, which is 39z, and then 3 times -23, that's gonna be 69, all right? Negative 69. And then here you're gonna have negative 24y plus 6z equals, I need y'all to pull out your calculators for me, negative 30, because we're gonna get some big numbers, okay? Y'all ready for me? All right, so the y's cancel. 39, negative 39 plus 6 is gonna give you a negative 33, negative 33z, and then you got 69 and 30, that's gonna give you 99, negative 99. I don't need your calculator. All right, so when you divide by negative 33, what does z equal?
3.
Z equals 3. Did anybody get there? Good. Z equals 3. So then you're gonna take this 3, let's plug it into this one because it ain't making no noise right now. So we plug this 3 into this equation. That's where we are now. Substitute it to step 2. So it'll be negative 12y plus 3z equals negative 15. So that's negative 12y plus 9 equals negative 15. You subtract 9 on both sides, you're gonna get negative 12y equals, what's that? Negative 24. Y equals positive 2. How many students have that? Yes. And then we're going to take this 2 and this 3 and we're going to plug it into the original equation. Let's put it in the A. So it'll be x plus 5y minus 2z equals 5. That's a 3, right? So that's x plus 10 minus 6 equals 5. So that's going to be x plus 4 equals 5. Subtract x equals 1. So we had x, y, z. 1, 2, 3. How many students had that? Good job. How you feel about this? Yeah, it's just a lot, right? Let's just admit it's a lot of work. It's a lot of work, right? All right. So let's take a look at this next one. So substitution is the best method when at least one equation is isolated. So let's look at this example here. We got 4x minus 2y plus z equals 5. Z equals 8y plus 1 and 6x plus y minus 2z equals negative 8. All right, so we got an isolated situation. We know what z equals, right? So we're going to substitute this into both of these equations, so then we'll have an isolated situation, right? So it'll be 4x, let's do it. 4x minus 2y plus z, 8y plus 1 equals 5, right? We can drop these parentheses since there's nothing on the outside and combine like terms. So that's 4x plus 6y plus 1 equals 5. And we can subtract 1. So 4x plus 6y equals 4. All right? So that's that equation. Do the same thing. Substitute the z value into the second equation. That's going to give you 6x plus y minus 2 times 8y plus 1 equals negative 8. Now here we got to distribute, right? Make sure you draw your arrows. So that's 6x plus y minus 16y minus 2 equals negative 8. Combine our like terms. Bop, bop. So that's 6x minus 10y minus 2 equals negative 8. And then we're going to add 2 to both sides. So we end up with 6x minus 10y equals negative 6.
Where'd you get 10 from?
Huh?
Where'd you get 10 from?
Oh, in my head this was a 6. It's not a 10. It's 15. Good catch. Alright, because that's a 1. I don't know why. In my head that was a 6 there. All right, so we got 6x minus 15y equals negative 6. So now we got our two equations, okay? So now we're gonna put this, let's bring this over here, okay? So we'll have 4x plus 6y equals 4, and 6x minus 15y equals negative 6, okay? All right, now we can get, let's get this one, let's get the x's to cancel out, okay? Now again, think about the least common multiple between 4 and 6, which would be what? 12. Good. All right, so we're gonna multiply the top, since they're both positive, let's make one of them negative. So we're gonna multiply the top one by negative 3 and the bottom one by 2, right? So that's gonna give us negative 12x minus 18y equals negative 12. And then we got 12x minus 30y equals negative 12. Is that negative 12? Is negative 12? Yeah. All right. These cancel. So then you get negative, same sign, add and keep, negative 48y equals negative 24. Okay? Divide. Y is going to give you 1/2. Right? 24 over 48. Okay? Let's take this y and we can plug it into, where is that? Where are they? So where is that? We can plug it into this one, or let's plug it into this one, because that's even, right?
Plug it into the z equals.
Or we can plug it in. We can do that. Yeah, to get z. There we go. Good. So z equals 8. That's a good idea. 8 times y plus 1. So then it'd be z equals 4 plus 1. Z is 5. So we got y and z, and we can plug it back into an original equation, right? So 4x minus 2y plus z equals 5. So that's 4x minus 1 plus 5 equals 5. All right, 4x plus 4 equals 5, subtract. You're gonna get 4x equals 1. X will equal 1/4. So we got 1/4, 1/2, and 5. So our solutions are 1/4, 1/2, and 5. X, Y, and Z. Okay, how many students got that? Good. So essentially this is solving system of equations with 3 variables, right? You want to choose 2 equations to cancel out a single variable. Choose another pair of equations, usually, remember we labeled them, right? It'll be B and C, and you'll cancel out the same variable that you canceled out here, right? Then you're going to solve by system of 2 equations like we did here, right? And then substitute the given value into an equation. In this case, we just substituted it into the isolated variable equation, and then we plug the 2 solutions we found into an original equation, right? And then we get a 3 number solution, okay? So, if you haven't already, don't forget to like, subscribe. If you got any questions, comment below. Until next time, MrDoTheMath out.